Determining living reagent and excess reagent. Basically what the living reagent is the substance that runs out first in a chemical reaction, and the excess reagent is basically the substance that doesn't run out after the living reagent runs out. But the reason why the living reagent is so significant in just solving a problem because it controls the amount of product that you're allowed to create because it runs out first. So it doesn't matter how much excess reagent you have left, all it matters about the living reagent. And then to really find out the living reagent and integrate the limiting and excess reagent in a problem is to follow these three simple steps, which is to first balance the equation, and then 2 is to convert the information into moles with the information you're given, and then 3 is to just compare the mole ratio, and then from there you will be able to determine the living reagent. And then here is a sample problem. You want to react 10 grams of iron 3 oxide with 10 grams of carbon monoxide to produce iron and carbon dioxide. Which of the following is the living reagent? So this question is very straightforward, and here's the work. So here first, the first step was to balance the equation, and I balanced the equation here, and basically if you do not know how to balance the equation, all you need to do is just have the same number of one element on this side to have the same number of that element on the other side. So here we have 2 iron, we have 6 oxygen, we have 6 oxygen, and 3 carbons, and 3 carbons. That's basically how you balance the equation. And then step 2 was to convert the given information into moles. So here, this was really easy because both of our reactants have the same mass, which is 10 grams. And then basically the equation we're going to be using is mass over molar mass, or simplified G over AMU equals mole. And here for iron 3 oxide, it's 10 grams over the AMU, which is, if you add it up for iron 3 oxide, is 159.7. If you divide that, it equals to 0.063 moles of iron 3 oxide, and that's the amount of moles we have in this equation. That's the amount of moles. And then if you do the same thing for the carbon monoxide, just get 10 grams divided by the AMU, which is 28.01, you get 0.357 moles of carbon monoxide, which is basically the same thing. This is the amount of moles we have in the equation due to our mass, or how much mole we're able to create. And then 3 is to compare the mole ratio. So here, it's kind of a bit of stoichiometry where you just compare the ratio from iron 3 oxide and carbon monoxide with the mole. So the ratio is 1 to 3, so it means that for every 1 iron 3 oxide we create, or however many we create, we should get 3 times more for carbon monoxide. So the answer should be 3 times more for carbon monoxide. So here it's 1 mole iron 3 oxide over 3 mole carbon monoxide equals to 0.063 moles of iron 3 oxide over X, because we're trying to figure out how much carbon monoxide we will produce if we use all of the moles for iron 3 oxide, because we're going to figure out the living reagent. And then here, if you just cross multiply and just simplify it, it becomes 0.189 mole of carbon monoxide, meaning that if we use all of iron 3 oxide, that's the amount of moles for carbon monoxide we will make. And because this number is less than the actual amount that we're able to create, it means that iron 3 oxide is the living reagent because it ran out first. Because this number is too small, meaning that we have too much carbon monoxide, meaning that this is the excess reagent. And really, when you compare the mole ratio, you don't need to choose. Doesn't matter which number you choose, because you don't know what the living reagent is, but you can choose whichever one, and you'll get the exact same answer. Here for B, I did the exact same opposite. So I use carbon monoxide instead of iron 3 oxide. So 3 over 1 and then 0.357 over X, and then X is basically the exact same thing, how much iron 3 oxide will produce if we use all of the moles for carbon monoxide, and then you cross multiply, simplify, becomes 0.119 mole of iron 3 oxide. So basically that means that if we use all the moles for carbon monoxide, then we will get 0.119 moles of iron 3 oxide. But then, see, this number is bigger than this number, meaning that because this is less, that means that we don't, the limit, this runs out before we're able to use all of this. Means that iron 3 oxide runs out before we're able to use all the carbon monoxide, showing that this is once again the limiting agent. And also, easier way is if the number you get, so whenever you compare the mole ratio, an easier way to think of it is whichever number you get, if the number is less than the actual mole, then that itself is the limiting reagent. So in this case, we use iron 3 oxide, and then because the amount of moles we try to find out is less than the amount of moles we actually have, this iron 3 oxide is the limiting reagent. And same thing goes for this one, B. And that is all.